everyone. Good morning. Welcome to A-Level Computer Science. My name is Inga Tupama, and I'm the A-Level Computer Science teacher. This morning, I thought would have a lesson on algorithms. And the reason I've chosen this lesson is because algorithms are quite central to A-Level Computer Science. So I'm just going to start with playing my presentation. And then we'll have a look and see what algorithms are all about. Okay, so algorithms basically is writing down steps to solve a problem. And I've written down a few keywords that underpin algorithms. One of them is called computational thinking. If you've done GCSE computer science, then you'll probably have an idea of what computational thinking is. And then there's an approach called divide and conquer, which I'll explain in a few minutes. And when an algorithm is being designed, computer programmers look for which is the most efficient. So I want us to talk a little bit about the efficiency of algorithms as well in today's lesson. So there are two things I'm aiming to achieve in our lesson today. The first thing is I'd like us to find out about this approach called a divide and conquer, used in the context of search algorithms. And then secondly, I want us to discuss a little bit about the efficiency of how to compare algorithms. What makes a good algorithm over, or a better algorithm over another algorithm? A few terms that we're going to, or that are going to feature in our discussion today: search algorithms, linear search. Those of you that have done GCSE computer science, if you have, will know what a linear search is. Binary search, efficiency analysis, that's comparing the efficiency of algorithms, and a divide and conquer approach. Now let's talk about searching for information. And I'll pick the most common information searching that we do, and that's searching for information on the web. We know there are billions of web pages out there. And isn't it amazing how quickly results are returned? At the click of a button, and we have all these results returned. So how do they do it? I'm just going to find out, first of all, whether, are you able to communicate with me with your microphones? Because I'd just like to find out whether anyone knows what a linear search is. So I'll just give a minute. If you're able to switch on your microphone and you know what a linear search is, can you please describe that? And if you're not able to use your microphone, I'll just move on. Okay, I think I'll just move on. So linear searching is one approach that's used for searching for information. Now, a linear search starts in a list from the beginning, going through item by item, trying to find an item, that's being searched for. Now, is this the approach that is done in web searching? Can you imagine all the billions of web pages out there? Would it be efficient for searching to be done in a linear fashion, starting with one web page, go to the next web page? That doesn't sound like a very sensible or practical approach. Computers aren't actually fast enough. Much as we think computers are great, if they were to adopt a linear search for looking for information on the web, going through it from the beginning, page by page, that would take very long. So there must be some other cleverer search algorithms out there, more clever than the linear search. Okay, let's just move on. So the linear search, how does it work? What if you have 1 million names in a list? How would a linear search look for a single item from that list? And what if you were looking for a book to read on a shelf of books in random order? So these books haven't even been ordered, in a certain way, and you're trying to look for a particular book. Or what if a teacher is looking for a particular student's exam paper amongst a large pile of exam papers? How would that work? So with a linear approach, it's doing it, as I said, from the beginning of the list, looking at each item before moving on to the next. Now that would work fine for small lists, but if you have 1 million items or 1 billion items, that would take forever. Right, now I want us to play a game. I'm sure you're all familiar with the game Guess Who. So with this game, Guess Who, I'm going to pick a character, an individual, and you have 20 questions for you to ask me in order for you to try and work out who I am. So I'm just going to give you a minute now, because I've thought of an individual, and I'd like you to write it down. Write down your question. So you've got 20 questions, write down a question, and you're trying to establish who I am. Okay. So I hope you're all doing this, writing down a question. Okay, now I'm going to ask you a few things. What do you think makes a good first question? So look at the question you've written, and what do you think makes a good first question to ask? And what makes it a good first question? Why have you chosen that particular question? Okay, at this point, if I was able to hear from you, that would have been great, to hear what you know, your answers are. So I'm just going to try and see what I can see in the question and answer screen. All right, okay, excellent. So now I can see some questions, right? Okay, Adnan, thank you for your participation. You've given a description of what a linear search is, checking each item in a list one by one. And Kaiser, right, okay, Kaiser has posted their first question asking whether I'm male or female. Right, sorry, I hope I pronounced your name correctly. Keziah, actually, the person I'm thinking of is male. Okay, the person I'm thinking of is male. So can you think of another question? And as you're writing your question, what makes a good first question? And what makes a good first question? I've just realized that I've written the same question twice, haven't I? My second question on that slide should have been, why does it make it a good first question? Okay, so your first question was whether I was male or female. Can we just focus on that before I go on to Vastal's question? Right, so Keziah, why did you think that question was a good one to ask? Are you male or female? And this is an open question to anybody else that can type in the meeting chat. So Keziah asked whether I was male or female. Why is that a good first question? Can anybody just type your answer, please? Why do you think that was a good first question to ask? Okay, Thomas says it separates the large group into two smaller groups. Excellent. So by asking whether I'm male or female, you've halved the number of possibilities immediately. So this is going to make it a lot easier for you to establish who I am. Okay, so that was a good strategy to adopt. Now I'm going to move on to the next question. That shall you asked whether I'm black. Now for the individual that I'm thinking of, no, the person is not black. Again, the strategy you're using there, Vastal, is you're trying to narrow down. So we started off with male, female. We've halved the number of possibilities. You've now asked whether the person I'm thinking of is black. No, the person is not black. Can you ask another question, please? So we're down to 18 questions. You have 18 questions. Anybody else like to ask another question? So we've had 2 questions so far. Let's move on. Let's try and see whether you can establish who I'm thinking of. So I'm not female. I'm male. I'm not black. One more question, please. Let me just see whether anybody's asking another question. Sorry, do they have blue eyes? Now that's a good one. Do they have blue eyes? Let me try and think. No, I don't believe they have blue eyes. But again, Luke, you've asked that question in an attempt to try and narrow down who they are. Is your character a sports person? No, they're not a sports person. And Vinit, you've said, is it Elon Musk? No, it isn't. Now, can I just stop with Vinit's question there? Is it Elon Musk? Now, you've asked that question, Vinit, sorry, after we've gone through a few questions. How many questions have we asked, by the way? We've gone to 1, 2, I think we've probably asked about 6 questions. By asking about one specific individual, you're ruling out all the others immediately. Now, if you were right, if it was Elon Musk, then that would be fine. But as it turns out, it's not Elon Musk. Am I a famous person? Adnan says, yes, this person is very, very famous. Another question, is your character fictional? No, Tabish, this character is not fictional. I'm just going to ask one more question and then I'll move on. So one more question. So very famous person, not Elon Musk. I think you meant to, Vatshao says, is the person linked to computer science? No, the person is not linked to computer science. Okay, let's just stop there. Thank you very much for your questions. Now, let's just move on. Now, I just want to consider the strategy that you adopted with asking those questions. So you were obviously trying to narrow down the possibilities. If there were 1 million famous people that you were thinking of this at the start, okay, after asking your question, the first question that were asked was whether I was male or female. So immediately you halved the number of people it could be. Okay, so from 1 million possibilities, you'd halved it down. Now, how many questions would you need to ask in order for you to work out who I am? Let's just look at this. If you look at this counting down here, so from 1 million, we halved it down to 500,000. If you ask another question, you're halving it down to 250,000. And after 10 questions, you could have narrowed it down to only 1,000 people. Okay, I don't know how many questions we've asked. I think you've probably asked about 10, haven't you? You've asked about 10 questions. You've actually narrowed it down quite significantly to the number of possibilities. And if you keep going, if we had time, you might find that after 20 questions, you're only down to 1 possibility. Okay, so I see some of you have identified what the algorithm is, because Munaf says it's just like a binary search. Indeed, this is a binary search. So those of you that do GCSE computer science would be familiar with the binary search. Munaf, can you just type in the meeting chat or give me a description for what a binary search is? Oh, and I can see Adnan has given me the number of comparisons, I think. Is that what you're working at? The number of comparisons or questions you'd ask? Right, okay, so Thomas now wants me to tell you who it was. Okay, I'll put you out of your misery. I'll tell you who it is. Donald Trump. I was thinking of Donald Trump. So I don't know how many questions you'd have asked me to work out who Donald Trump was. Now, what's this got to do with computer science? You know, why have I asked you all these questions? Well, I started off the lesson with talking about searching for information. We know that in computer science, a lot of what is done with programming is writing algorithms. And these days, a lot of these algorithms are to do with searching for information. In fact, this morning, I was listening to the radio as I came in, and Mac Hancock, oh, he's not Hancock, is he? The health secretary, was on the radio talking about this NHS app and collecting data. And people are a bit concerned about, you know, our health records or data on individuals being shared with the likes of Google. And Matt, is it Hancock? Matt Hancock was trying to justify and explain why it's important for the NHS to have all this data. So as computer scientists, we are involved a lot with writing algorithms, and a lot of the algorithms that we write are linked to searching for data and working with data, looking for patterns. In fact, with the NHS data collection that they're doing, it's been effective by looking for patterns in the data. Okay, so this searching strategy that you used for the game that we were playing was using something called a divide and conquer approach. Now I'm just looking at what Munaf has written. He's given us a description of what a binary search was. So that method of trying to narrow down or to halve the number of possibilities is a type of binary search. And Munaf has described it as binary search is an algorithm that basically needs to have your data items in order. So if you have a list of items in order, and it follows the method of halving and searching, which is called divide and conquer. So you're dividing the problem in half, or you're dividing the data set in half. And with each search, you're reducing that problem or the data set by half. Okay, so thank you, Munaf. That was true, or correct rather. The binary search is an algorithm that searches data that's in a certain order and works by halving the data set each time. Adnan says, if you work out n, so n is the number of items, You'll get how many questions you need to ask, indeed. That's in the worst case scenario, Adnan. So in the worst case scenario, how many questions would you need to ask? Okay, because in the best case scenario, you could have guessed that it was Donald Trump with the first question, couldn't you? Okay, but in the worst case scenario, you'd have had to ask a few more questions than that. Okay, what else can I tell you about that? So that's a divide and conquer approach. It's called divide and conquer because you're dividing the problem and you are conquering the problem, solving it effectively. So that's very different from the linear search. With the linear search, you know, it took a lot longer, or it would take a lot longer because you're going through your data sets sequentially from beginning to the end. Right, so I hope you enjoyed that. That was just, and from the answers you were giving me, I can tell that, you know, some of you, I'm not sure that's all of you, have done this at GCSE. If you're wondering how it's going to be different at A level, actually, here's a good one for you. We build on that knowledge that you already have, and we look at other searching algorithms. We look at other data structures. If you had to write a solution to this linear search or binary search, you'd have to do it using structures like arrays or lists. At A level, we learn about more complicated data structures like trees. There's something called a binary search tree, which would work quite nicely actually for this binary search algorithm. We use things like hash tables. So there's a lot of progression to A level. Okay, so I'm going to stop now with the algorithms and just finish off with sharing some links with you. Now this slide that I'm showing you now is going to be posted to you. At WQE, we use C# for programming. Most of you, I think, use Python, I believe, for your programming. We use C#. So it would help if you make an early start with learning how to code in C#. So I've put together a few links for you to use over the summer holiday. There's one that's called Solo Learn. You can download it as an app on your phones. There's a website called W3 Schools, which you may have come across. Then there's Code Academy. Now, these are all online platforms. They're not the actual IDE, but they're useful because they have online tutorials. I would suggest trying to use one of those 3 online learning platforms first. And then if you download Visual Studio 2019 Community, this is the IDE that we use. It's free. And then, you know, maybe just do a bit of practicing with, you know, getting into C# so that when you start in September, you'd be a bit more comfortable. You know, you're making a good early start with it. Okay, so let me just minimize this now, and I'm going to answer some questions now. As I said, this will be emailed to you, so just look out for it in your post. Okay, right, I'm now going to do some question and answer. Let's see what questions we have. The exam board we use, so Muhammad's asking which exam board we use at WQE. It's OCR. Sorry, let me just answer that there. Yeah, so the exam board we use is OCR. I'm just going to see if I can type my, no, I can't answer, I can't see where to type that. Yeah, so it's OCR. Would it be easy to transition from Python to C#? Arian asks. Absolutely, it is very easy to, do you know, with programming, I always say, once you know one programming language, to transition to a new or different programming language is not that difficult. It's a bit like, once you know how to ride a bicycle, then you can ride any type of bicycle, can't you? So it's the same with programming, because the basic programming constructs, if you like, are there in all the programming languages. So in C#, you're going to find selection, iteration, you know, like for loops, while loops. It's just a case of learning the syntax. It's just a case of learning the IDE and becoming familiar with it. There's a little bit extra that we do with C# and at A level. There's a different style of programming called object-oriented programming. Now, we don't do that in the first year, but you know, we kind of like get you started with the groundwork, learning about OOP. So there's another progression from Python and another progression from GCSE, where you learn a different style of programming. Python, you can use OOP in it, but yeah, you can do it in Python as well. Okay, I hope that answers your question, Arian. And Adnan is asking, do we use any JavaScript? Yes, we do use JavaScript. It's just a small part of the A-level curriculum, but it is there. In fact, the current first-year students have recently been working on websites. So JavaScript is a web development language, and they've recently produced some websites using JavaScript, HTML, and CSS. But it's not, you know, in terms of if you're comparing how much time you spend with the web development, I'd say it's just a very small part of the A-level. Right, Munaf is asking, how many types of programming language do we need to have an understanding of? Well, for the whole course, it's really best to maybe just use one programming language. So we use Visual C#. Now, having said that, well, I say that that's like the main programming language we'll be using, and then we'll do a little bit of JavaScript, and we also do a little bit of SQL. So in answer to your question, I'll probably say 3, but the main one is C#, a little bit of SQL, and a little bit of JavaScript. Typically, how many lessons would there be this week, Vinit asked. Now, Vinit, obviously, you know, because of the current situation, this year has been a very strange one, but next academic year, starting September, we're going back to a timetable that involves classroom teaching. It's 4 lessons a week. 4 lessons a week, I believe, is what we've gone back to. That's what we had before before COVID, and I believe we are returning to that. And Tasha says, is this work instead of or as well as the transition work on the WQE website? Now, I'm not sure which transition work you're referring to, Tasha, but what I will say is this work is specific to computer science. So have a look and see whether the transition work you're referring to has broken it down to subjects, and if so, then it will be this one. If not, then, you know, this is just my suggestion to students to make an early start with getting ready for A-level computer science. Okay, Vatchal says, what's the difference between C# and Python? It's something called, well, they're different languages. They have different styles. Programming languages are different in their style and syntax. So maybe I'd say different in style and syntax, different in the IDEs that are available, but the basic programming constructs would be the same in any programming language. So you're always going to get statements to allow you to input information, output information, use selection, iteration, storing data. So the only difference is in the syntax. So it's all about learning a new language and learning what the syntax is in that language. Path asks whether C# is an object-oriented language like Java. Indeed, it is. It's less strict, shall we say, less, and by that I mean with Java, the only way you can write code is in an OOP manner. Whereas with C#, you can get away with writing code that doesn't necessarily have to be fully object-oriented language, but certainly C# is an object-oriented language. And Christopher's asking if the summer work PDF directs us to begin learning JavaScript as well as C# as an extension activity. Right, Christopher, by your question, I think what's happened is the college has probably sent you summer work, which I issued last year. So I just need to check with the college what's been sent to you. I would say focus on the C#. Do the JavaScript by all means, but I would say, can you please focus on the C#, please? Okay. In previous years, I've asked students to do the JavaScript because it's just like a fun thing to do. But it will probably be more beneficial to focus on the C#. Amma, I think I answered this question before. We use OCR. The examination board is OCR. And Path is asking, do we cover any concepts of artificial intelligence, data science? Absolutely, we do. We do it in two areas. There's one discussion area which looks at how looks at how the use of technology impacts on different sectors. I describe that as a little bit of an ICT type discussion. On the practical side, we also talk about how algorithms are used in AI. And there's an opportunity with your projects. So the A-level computer science involves a project, it's a programming project. And students who've got an interest in AI, there's an opportunity for you to do something that involves developing something that's an AI, whether it's, data collection, looking for patterns in data, and just trying to demonstrate or develop your knowledge of what AI is. What's the specs of the computers in the college? Adnan asks. Ooh, I know in terms of software, we've got the most up-to-date software. We've got Windows 10. The RAM and amount of capacity, you won't have a problem with that. They're really most up to date. I'm just thinking it's probably I don't know, eight maybe RAM, 8 gigabytes probably, or 16, I don't know, but they're very up to date. We have no issues. I haven't had any complaints about slow computers or out of date software. Okay. Mohammed asks, how often would we need to revise outside of college for computer science to achieve a high grade? For any A-level subject, the advice is for every subject, you need to be spending at least, I think it's 1 hour per subject per week. So if you're doing 3 as a minimum, so if you're doing 3 A-level subjects as a minimum, I would say you need to be spending as a minimum at least 3 hours outside of class independently, and that's on top of doing things like your homework, etc. So with A levels, you definitely need to be an independent learner. Vatshao is asking, we've only got 1 minute left, by the way, so I'll just wrap up the last few questions. What percentage of this course is comprised of coursework? Coursework is 20%. Okay, so 20% of the course is coursework. And Parth is asking whether students can bring in their own laptops for use in the classroom, or is it mandatory to use the college computers? Well, it's not mandatory to use the college computers, but to be honest, most of our students use the college computers. I've had 1 or 2 students, particularly in the COVID situation, asking if they can bring their laptops. But to be honest, I think everybody finds that the laptops are high enough spec for them to make use of the college computers. Mohammed, you're asking about where to find the links for the summer work. It'll be sent to you. I've asked for these for that information to be sent to you by email, so please just look out in your email. Zane's asking whether we learn any form of ethical hacking. Yes, we do. There's a little bit of a discussion topic, more as a discussion rather than learning how to do it, Zane. Right, last 2 questions, and then I'm going to stop. Is the A-level more difficult than GCSE? Is it a big jump? I wouldn't say it's quite a big, I wouldn't say it's a huge jump. It builds on the GCSE. And if you've got the GCSE skills, you do well. Having said that, if you haven't done GCSE, please do not worry. I've always had students that haven't done GCSE and that go on to do well and catch up. Okay, folks, we've run out of time, so I'm going to say goodbye to you now. I hope you found that useful. If you've got any further questions, please don't hesitate to send those questions in to the college. And I look forward to seeing you hopefully in September. Have a lovely summer and good luck, and see you in September. Bye-bye.